Welcome to this SolidWorks tutorial, guys. In this tutorial we will be designing this part in SolidWorks, and then we will perform simulations or FEA, which is called finite element analysis in SolidWorks. So let's begin. Click on part and click OK, and after that make sure that you are working in millimeters, or if you are working in inches then select IPS. Change the background to plain white for better visualization. Then click on front plane and click on sketch. Now we are going to make the first sketch. So here select line, and from this center point to this point here create a vertical line. Then here select 3-point arc, and this is first point, second point and third point in space. Make an arc. Now select this point and make relation tangent, and after that select line, and from this point to here this point in space make a line. Then click on this line and make relation horizontal so that this line can be straightened. Now select this point and make relation tangent. Okay. Now select smart dimensioning tool and here specify the length of this line. I am specifying as 75 millimeter, and after that we need to specify the radius, which is 12 millimeter, and finally we have to specify the length of this line, which is 55 millimeter. After specifying these parameters, now we have to go to features and select extruded boss base to convert this 2D sketch into 3D model, and here specify 8 millimeter as thickness, and here specify 45, and as you can see this length is quite smaller, so here specify 55 and check this box. Okay, now we have to cut 2 slots, so select this face and click on sketch. We will be creating a slot and will cut it, but before that select here center line, and from this midpoint to this midpoint here create a reference line. This will be a center line, and then select here straight point slot and make a straight point slot here like this. Okay, now we need to define it. Select your smart dimensioning tool and here specify the length of this line as 25 millimeter, and here specify the radius for this arc. I'm specifying as 5 millimeter the radius. Now go to features and select extruded cut because we want to cut this sketch from the geometry. So here specify through all and check this box. Now we need to cut another slot, so select this face and click on sketch, and again we want a reference center line. So from this point to this point here make a reference center line, and after that select here the straight slot and make a slot here at this midpoint, and after that we need to specify the length of the line and the radius for the this arc. So the radius of this arc is the same as 5 millimeter and the length of this line is 20 millimeter, and we will be doing the same thing here. We want to extrude cut it, so select here extrude cut and here specify through all and check this box from here. Okay, now we need to specify some fillets, so select fillet tool and here select these 4 corners, first, 2, the third one and the fourth one. 10 millimeter fillet radius is fine, and check this box from here. And now the part is ready, so let's enable the simulations. So you need to check this simulation, SolidWorks simulation from here and click OK. When you click OK, the simulation tab will get enabled. So here is the simulation tab, and as you can see we have only the model tab. So when you click on new study and here you select static and click OK, a new tab will be enabled for the simulations. And this is the simulation tree, so right click here on the part and here select the edit material or apply material, and here you can apply any material you like. I'm specifying this alloy steel SS, and click on apply and close this. And as you can see, the color of this part has been changed. It means that the material has been applied. So skip this connections for this tutorial and right click here on the fixture and click on the fix geometry. And since we want to fix the back side of this geometry, so in this window I am specifying this back side and check this box from here. Okay, now right click here on this external load and click on force, and in this window we need to specify this top surface. So click on it and here specify the amount of load. I'm specifying 250 Newton, and here you need to specify SI as units and check this box from here. After that we only left with the mesh, so click on this create mesh and check this box for the mesh parameters, and here you need to specify the mesh size. So I'm specifying as 3.5. This will divide the whole body into small parts, and here you can see the mesh will be mesh is applied. And now you can simply click on this run study. It will take some time. It is based on the computation power of your computer or laptop. And here you can see we have the values for stress, strain and displacement available now, and here are the values for stress. So let me animate. Right click here and click on animate, and here you can see our part will get deformed like this, and the red zone is basically the danger zone where the most stresses are being applied, and as you can see it from here as well. So cross this window from here, and if you want to show the value for the displacement, here are the value for this displacement, and here are the values for the strain as well. Now right click on the stresses and click on show, and if you want to make some changes, if you want to fine tune your model, go to your model and edit this extrude, and if you want to decrease the thickness, I'm decreasing it by 1 millimeter, and check this box and come back to the simulations and run the study again. It will take some time. We can fine tune our model. If it can handle the loads, then we can decrease the thickness so that our material can get reduced and the weight can get reduced as well. So we can optimize our design as per our FEA results. And as you can see it from here, you can animate the load and you can verify as per the yield strength as well. So that's how we use FEA to fine tune our model. If you find this video helpful, then please hit the like button and subscribe to my channel. Thanks for watching.